Hi everyone. The topic of my project is self-supervised depth completion using RGB guidance. So the motivation for this project is to solve the problem of dense modeling given a sparse model of a scene. Such a sparse model could be obtained using standard image-based 3D reconstruction methods. So given registered camera poses and corresponding sparse 3D points, dense depth maps need to be estimated, which are then fused into a 3D point cloud of the scene. Some challenges that impact classical approaches is presence of textureless surfaces in the scene, lack of overlap, as well as varying illumination of objects and surfaces, which leads to incomplete depth maps. So the task of depth completion has been set up as a deep regression problem where I train a neural network to learn to predict a dense depth map given a sparse depth map plus the corresponding RGB image. I use the NYU depth dataset to train the network and use random sampling to generate 200 sparse depth samples per input using the ground truth depth maps. I implement an encoder-decoder based on residual layers and skip connections between corresponding encoder and the corresponding decoder layer. The sparse depth maps and the RGB images are independently processed through 3x3 conv before being concatenated as an input to the network. The last layer is a 1x1 conv layer which outputs a single channel depth image as a prediction. There are three loss functions that I use to train this model. L depth is nothing but L1 reconstruction loss over all the valid depth pixels. L smooth is computed using second order derivatives of depth predictions. Basically, it encourages neighboring pixels um, to have similar depth values. And L photometric is computed using a nearby RGB frame by warping it to the current RGB frame by first estimating its pose with respect to current frame and then using that and the current depth predictions. For inference, only the current RGB frame and the sparse depth map are used as inputs to the network. So here are the results. So these are qualitative and quantitative results using the validation set. So the image here shows 8 validation test examples. The leftmost column is the RGB input. This column, although I think if you zoom in, you may be able to see, but this column is the sparse depth map. So every depth map has random 200 depth samples. The third column is the ground truth depth map, and the last column is the predicted depth output from this network. And as a comparison to a baseline that I have been following is this paper from MIT. They achieved a root mean square error of 0.23 on the same depth data set. And I basically followed their sampling strategy. Basically, they also sample 200 depth samples per input. And my model was able to achieve 0.15 for root mean square error. And yeah, so this baseline paper, they use a ResNet 50 based encoder decoder model. Okay, thank you very much.